So we have our formulas for slope, which we talked about yesterday, rise over run. This is probably the most important one, y2 minus y1 over x2 minus x1. And then, does anyone remember what standard form, the formula for standard form is for a linear function? We actually saw it yesterday a lot. Joseph? Good. Ax plus by equals c, where a and b can be any rational numbers. Point slope form. Anyone remember that one? Hint, y minus. Brett?
Y minus y1 equals m times the quantity x minus x1.
Good. So in this equation, remember that m stands for the slope, and then the point x1 comma y1 is the point. So the actual y and the x that don't have the little 1, they stay there. So an example of an equation in point slope would be y minus 2 equals 3 times x minus 5. Like the y and the x always stay in the equation. The only thing you'll be plugging in for is the x1 and the y1. And then slope-intercept we talked about yesterday, y equals mx plus b. Okay, so they're going to give us some information and they're going to ask us to write an equation in multiple forms of the line. Depending on what you're given, you're going to choose which one to start with. So sometimes I'll give you a point and the slope, and I'll ask for it in slope-intercept form. You won't have enough knowledge to plug into this formula yet. So you want to look at what you're given and select either, most likely, point-slope form, and begin from there. So we're doing this, I actually want to add, we're going to do it in point-slope, slope-intercept, and in standard form. So we're going to write an equation in all three forms that would contain this point and have a slope as given. So notice I am given a slope and a point. So my slope is my m, label that with an m. My point is x1, y1, because that's the first point that they're giving me. So based on this information, the formula we want to start with, okay, so step 1 is to start with point slope. Y minus y1 equals m times x minus x1. Because that's the information that they gave me. They've given me a slope and a point, so I'm going to start with point slope. Okay, substitute in the values. So y minus a negative 1 equals m, which is negative 1/2, x minus x1, which was 8. Now we know minus a negative can be changed to be a positive, right? So I'll go ahead and change that to y plus 1. You could write an additional line of work, but I'm going to be short on space, so it would be y plus 1. So that's actually one answer, right in point slope form. So go ahead and put a box around that. That's one of the equations. They also want us to put it in slope-intercept form. Okay, so step 2 will be slope-intercept form. To do that, we have to distribute first. So the first thing we're going to do is distribute the 1/2. Excuse me, the negative 1/2. So when I multiply negative 1/2 times x, I'm going to get a negative 1/2 x. But a lot of students mess up when they multiply negative 1/2 times the second term, which is a negative 8. So first of all, negative times a negative is going to get me a positive, right? And when you're multiplying 8 times 1/2, you may want to make it into a fraction by putting it as 8 over 1. 8 over 1 multiplied by negative 1/2. To multiply fractions, you just multiply tops and bottoms. So again, we already did negative 1 times negative 8 will get me a positive 8. 2 times 1 will get me a 2. Bring down what we had over on the left. And then we can simplify. We know 8 divided by 2, that's just 4. So all I did here was simplify. Then the last step is to get y isolated so that it's in the form y equals mx plus b. So I'm going to use inverse operations. I see a plus 1. I know the inverse is to subtract 1. So I will get y equals negative 1/2 x. 4 minus 1 is a positive 3. Box that. That's answer number 2. And then I added in that we also want to put it in standard form. Now remember, standard form is ax plus by equals c. So how can I rearrange this equation to get the x on the other side? Joseph? Good, you just look at the symbol here. This is a negative, the inverse is a positive. So we're going to add 1/2 x to both sides. And then we will put it, we cannot combine these are not like terms, 1/2 x and y, we can just write them next to each other. So 1/2 x plus y equals 3. Now some teachers, I think Mr. Cola might be one of them, will make you get rid of the fraction. Does he, or does he let you leave the fraction? You're leave it? Okay. We used to, whenever I was in school, we had to get rid of the fraction. They told us a, b, and c had to be integers. And so we'd have to multiply everything by 2 or something to get rid of the fractions. But for my class, this is perfectly fine. The Keystone also accepts fractions for the standard form. So that's why they changed it. All right, why don't you guys try the next one? So the first step is to find slope. Using the formula y2 minus y1 over x2 minus x1. So that's why I gave that slope review worksheet to review how to do slope, because you'll need to utilize that in this lesson. So we'll label point 1 is our x1, y1. That's point 1. Point 2 is x2, y2. And we'll have to substitute into the slope formula. So y2 is a negative 1, minus y1 is 5. So negative 1 minus 5, over x2 is 4. There's a minus in the formula. x1 is 1. So negative 1 minus 5 is negative 6. Perform the operations in the top. 4 minus 1 is 3. And then you do want to simplify this when you can. So negative 6 divided by 3 is negative 2. This is our m value. So in the last question, they gave us the slope and a point. So we went straight to point slope. This time they didn't, so you have to find the slope first. And then we're going to follow everything we did above. So the second thing is to go to point slope. Which those of you that are struggling, which I saw a couple of you, you probably want to write the formula every time until you get comfortable with it. So write out y minus y1 equals m times x minus x1. Eventually, at some point either in geometry or in algebra 2, you get to a point where you don't have to do that anymore. But until you feel confident plugging stuff in, I would take the time. Now, you can actually use either of the 2 points. I like to do the first one because it's already labeled x1, y1, just like this is. And then we're going to apply the slope as well. So we just have to look up what is y1. y1 is 5, so this will be y minus 5. Equals m, I just found, to be negative 2. And then we have x minus x1. x1 we have labeled as 1. On your homework, I think you only have to do it to this point. Okay, I think it just says put it in point slope form. I want to practice rewriting it because I saw a couple of you struggling. So let's practice moving this into slope intercept and standard. So the next step, if I want to change it to slope intercept, is to distribute the negative 2 to each term. The left-hand side stays the same. So y minus 5 equals negative 2 times x is negative 2x. And then make sure when you distribute, it'll be negative 2 times a negative 1, which will get me a positive 2. Last step to get it into slope-intercept form is to move the 5 over. So using inverse operations, I would add 5 to both sides. Negative 2x, 2 plus 5 is 7. Well, that's slope-intercept. And then I also added into the directions, let's put it in standard form, which standard form is actually, people think it's hard. It's really easy. It's a one-step move. All you have to do is use inverse operations to move the x over. So I see a negative with the 2x. If I want to move it to the other side, I use the inverse operation, which is to add 2x to both sides. And so I'll have 2x, and since y was a positive, you'll need to put in a plus y. You cannot just write 2xy. I think I saw one or two of you doing that. So when I move the 2x over here, I have to think, well, the y was a positive, so that's a plus y, equals 7. And those are all three forms of my line. Okay, we'll skip over the next one, just because it's kind of the same type of problem, but let's move to the back. Vertical and horizontal lines, so many of you screw this up, right? You do the opposite. And someone just taught me something. Hold on. Yes. Just like PEMDAS, you know, like is like an acronym. When I was tutoring a student from a different school district, she had written like a little phrase at the top, and I was like, what's that stand for? She's like, oh, this is to help us to remember what's vertical, what's the slope, and what's the equation for it. So for horizontal lines, the little acronym she had written was HOI. A horizontal line, this stands for horizontal. This 0 stands for the slope is 0. And then the equation will always be y equals. Whatever the number is. I don't know if this will help any of you, but some students always do it backwards. And then the vertical little acronym was VUX, so VUX, boy VUX. I don't know if you're going to memorize it or not, but if it helps anyone. Has anyone, other teacher, done an acronym for this? All right. We'll see if it helps this year. So the V stands for vertical lines. What is the slope of a vertical line? Yeah? It's undefined. Okay, so that's just going to go in this little box. So that's what the U stands for. The slope is undefined. Because it's infinitely steep. And if we calculated it, it would have a 0 in the denominator. And then the x at the end tells you that the equation will always be x equals a number. Okay, so when you see a horizontal line, the slope is always 0. The equation for that line is just y equals whatever the y value is. So this one, for example, could be y equals 2. Really, it's y equals 0x plus 2, because there's a slope of 0, but we just don't write the 0x part. So the equation of a horizontal line is always y equals some number. The vertical line, again, will have a slope that's undefined, but the x value is constant, so this could be like x equals 2. You literally just have to memorize that vertical is the x equals, the horizontal is the y equals. I used to say, if you look at this, there are v's hiding to remind you that vertical is x. Anyone have a better way to remember it that have had this multiple years?
If x equals 2, then it has to be
Oh.
It has to be x.
Has to be x. But people are like, that's the y. That's like y. That's what confuses them. But you can think that x is always 2. Where's my pencil? So the x value, this is 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. Okay, but you have to memorize this. So write the equation of a line and graph that is vertical and goes through this point. So again, vertical is going this direction. And using our little acronym or whatever you want, you have to remember that a vertical line always has the equation x equals something. Well, how do we know what that something is? It has to match the x coordinate of the point. So the equation should just be x equals 5. So a lot of students can graph it, but then they screw up the equation. Now if I plot this point, 5, -3, it would be vertical going through this point. And again, the equation is x equals 5, not x equals -3, not y equals -3, not y equals 5. Okay, the next one is horizontal, which anytime you see a horizontal, that's going to have a slope of 0, and it's going to be in the form y equals just a number. To understand what number that is, we look at the ordered pair and we look at the y coordinate. So this one should just be y equals 2 as the equation. Now when we graph it, it would occur at -2, +2, and it has to be horizontal. This is the equation of a line y equals 2. Go ahead and try the closure. For those of you taking the notes, you'll need more practice on this. So write the equation, and you only have to do it in point slope and slope intercept, so I don't make you do standard form. That goes through these 2 points.